This is section 7.4, exponential and logarithmic equations. So we're going to be solving equations this time. And when you have an equation, you have an equal sign. Here's one. And so we are going to solve equations. Whenever you solve an equation, you have you find a value for the variable that makes the equation true. So in this example down here, we're going to find a value for x that makes 2 times x plus 3 raised to the 5th power the number 812. That would make that statement true. And I have 3 options here, and we're going to try all 3 of these options. We're going to type this into the calculator to do it. So here I have my calculator, and I have typed into the graphing screen 5 to the 2x plus 3. Now I'm going to go to a calculator page, and I'm going to plug in these different x values. And so now I've taken the time and typed all of those x values into F1. You can get F1 when you hit the variable button, and F1 will pop up, so long as in the graphing screen you typed you typed the equation into F1. Okay, so then back on this calculator page, you can see I typed in all of those different x values, and for 2 of them, I actually got 812. And so those are both solutions. And what it turns out, these x values are just the same number written in a different way. And I guess the number is probably close to 0.581, but not exactly 0.581. Okay, so okay, so this is what we could do to solve the equation. We could try to substitute in every single number and see which ones work, but that would take too long. So instead, we are going to solve the way everybody solves, which is to apply inverse operations to every side of the equation until finally the x is alone. The goal in solving all equations is to get x equals. Sometimes this is very simple, but other times it can be tricky. And so we're going to practice several things to solve. All right, so we're going to solve some simpler exponential and logarithmic equations. To solve simple exponential equations, you want to get the same base on both sides of the equals. Okay, so in my first example, I have a 27 and a 9, and we've even done a few of these already. And 27 and 9 can both be written as 3 to a power. 27 is 3 to the 3rd, and then this is raised to the x, and so that will give us 3 to the 3x. And 9 is 3 squared. This means that my exponents must be the same, and so x is 2/3. And the next one, my common base, is going to be a 3 and a 4. So hold on, this 27, that's 3 cubed, and 64 is 4 cubed. And so if you think about 27 over 64, that's really 3/4 to the 3rd. Now over here I have 4/3 to the x, but I could reciprocate the 4/3 and make it 3/4 as long as I put a negative in the exponent with the x, because a negative exponent does a reciprocal. And so now when you match these up, negative x is 3, so x is negative 3. And then finally, this last example, 81 is 3 to the 4th power. And so this means that x plus 1 is 4, and so x equals 3. All right, so those are some of our simpler exponential functions. With logarithms, some simple logarithms, you want to isolate the log and then convert to exponential. So in this first example, I already have a log isolated, and so I will convert to exponential. This tells me 4 to the 64 equals x. And that's a large number that I'm not going to type in, but that would be your solution. And I know it's my solution because I have x equals, and that's when you're done. On this next example, be careful. The logarithm is only applied to x. If it were applied to x plus 1, then the problem would have been written different. It would be the log base 3 of x plus 1 in parentheses. So since it's not x plus 1 in parentheses, I need to isolate this logarithm by subtracting 1 from both sides first. Now I have the log base 3 of x equals 3, and the logarithm is isolated. I have only a log on the left, and so I will convert to exponential, and so x is 27. Now, in the last example, I do have the logarithm of x plus 1, so I can convert to exponential right away. 2 squared is x plus 1. I almost have x by itself. I've eliminated the logarithm, but now I just need a minus 1, so that's 3. All right. Another strategy that we are going to use when solving equations is to remember that logarithms and exponentials are inverse operations, and so they undo each other. And we also have already seen these two properties before. I'm just going to talk about it specifically. In this first example, I have the natural log, which is really a log base e. And so I have a log base e applied to an exponential with a base of e as well. That means that I'm undoing these operations. They're the same, or they're reversing each other. And so I'm only left with the exponent x plus 2. And then the same thing is happening in this next example. However, the common base is 2. I have an exponential with 2 as its base, and in the exponent, I have a logarithm with 2 as its base. So those cancel, and I have simply an x squared left. Okay. I'm going to solve exponentials now. And so the way that we solve these exponentials is to apply inverse operations until we have x all by itself. So starting with this first example, I have x in the exponent of the e. So I have a 7, a minus 2, and the e to all get rid of. But I'm going to do, you start with the number furthest away from the x. So I'm going to subtract 7 first. Negative 2 e to the x equals negative 2. Now I'm going to divide by negative 2, and so e to the x is 1. Now I have to get rid of the exponential, and in order to do that, I'm going to change to logarithmic form. So this tells me that the natural log of 1 is x. Also, you know the natural log of 1 is 0. You could have probably figured that out from here. The only power that gives you an answer of 1 is the 0 power. All right, on this next example over here, we're going to start by dividing both sides by 10. Then I'm going to take the natural log of both, you can think of it as taking the natural log of both sides, by the way, or just converting to logarithmic form. It results in the same thing. So here the natural log of e cancels. And then divide by 3. And you can type this into the calculator. I am not going to take the time to do that, but you can. On this next one, I'm going to take the log base 4 of both sides, or convert to logarithmic form. You can think about it that way. And then subtract 2 and divide by negative 1. So that's going to give me x equals 2 minus log base 4 of 0.145. Let me show you an alternate way of doing this one in blue here. I'm going to do it randomly in the middle of there. Some people, and especially if you have the TI-84, you should be thinking about doing it this way. You can apply a natural log to both sides of the equation, equals natural log of 0.145. And then this x, then you can think about exponent properties, and you can take the 2 minus x into the front. And then I'm going to divide by natural log of 4 at the same time. So I put the 2 minus x in the front, and then I divided by natural log of 4. And then I'm going to solve for x by subtracting 2 and dividing by negative 1. So that gives me negative natural log of 0.145 over natural log of 4 plus 2. This is the same thing as this answer, only with the change of base formula, and this can be typed into the TI-84. So if you have a TI-84, you can you have to at some point use the change of base formula in order to figure out the decimal answer. Those answers are the same. All right, moving on. I'm going to let you do this one on your own, and then I'm going to work with you on this one. This is a really tricky one. Okay. I did not leave enough room. So in this equation, Oh, this came from a money problem that was invested and compounded daily. This is r over n to the nt. And so when you solve for t here, you convert to logarithmic form. So 365t equals the log base 1 plus 0.065 over 365 of 4. And then divide by 365. Okay, let's go ahead and type that in and let me know what you get as well, because I want to make sure that you can type those in correctly. All right, this next question is one of the trickiest ones to solve for x with, and you do have to know how to do this. I'm going to give myself more room. Okay, so first of all, your x is, so I'm on this problem here. The x is in the denominator. So we're going to start this problem off by clearing denominators, which means I multiply both sides by e to the 3x minus 9. Then I'm going to distribute that 8. All right, now I can see I have no denominators. That's cleared up, and I have to solve for this x up here. I'm going to start by adding 72. Then I'm going to divide by 8. I don't know if that goes nicely. No, it can't go nicely. So then that equals e to the 3x. And then I'll take the natural log. So I'm converting the logarithmic form here. And then divide by 3. And you're all done once you type this number in. And then there's one more example. And in this last example, I have it written over there. This is sort of just a tricky, fun example. And what's happening here, you've seen these before in pre-cal, but we have a quadratic of e to the x. See how you have e to the 2x, e to the x, and then no e to the x? So if you let, like n equal e to the x, then n squared would be e to the x squared. And when you have a power to a power, those multiply, and so you have e to the 2x. And so when I rewrite this exponential function with n in place of e to the x, then this first term is actually an n squared. Then I have minus 6n minus 7 equals 0. This is a quadratic that factors very nicely and can be solved for n. And so I have two solutions, n equals 7 and n equals negative 1. All right, but that would be lovely if my question asked me to solve for n, whoever n is, but my question is asking me to solve for the variable x. And so you have to do this little back substitution. You solved for n, but you need to solve for x. N represents e to the x. We did that substitution. And now you solve your e to the x for x. So here, x equals natural log of 7. And then on this one, x would equal natural log of negative 1. And that should be, you should have red lights flashing in your mind right now, because you may not take the natural log of a negative number. And this is called an extraneous solution, and you have to be on the lookout for those, because you will have problems in which you think the natural log of negative 1 is an answer, but it's not, because you take the log of a negative. All right, moving on. Okay, so in this last part, we are going to be solving for x again, but now instead of being given exponentials and switching to logarithmic form in order to solve for x, this time we're going to have logarithms, and we will need to take advantage of the exponential form to solve for x. All right, so in my first example here, I have the natural log of 3x equals negative 24. And so I am going to switch to exponential form. This would give me 3x equals e to the negative 24. And then I can solve for x just by dividing by 3. So there's a lot of switching between logarithmic form and exponential form. That's what I'm doing the most. And the second example over here, the log base 3 of x plus 2. I need to solve x, so I need to get rid of, solve for x, so I need to get rid of the plus 2 and the log base 3. The first thing to get rid of is the log base 3 because it's furthest away. So the first thing you would do is add 2. So that's the last thing you undo when you're solving. So I'm going to switch this to exponential form, and x plus 2 will equal 3 to the 8. And I don't know what 3 to the 8 is, something very big. So then I'll subtract 2 from both sides, and x equals 3 to the 8 minus 2. And with a calculator, you can type in these numbers and get an exact solution or a decimal approximation. All right, and then in this last one, I have the natural log of the square root of 5 plus x equals 2. I'm going to think of square root of 5 plus x as 5 plus x to the 1/2. And then I'm going to put that 1/2 in the power in the front of the logarithm. And then multiply both sides by 2. Because I don't like square roots. So I get the natural log of 5 plus x equals 4. And now I'm going to switch to exponential form. And so 5 plus x equals e to the 4, and x equals e to the 4 minus 5. And then these last types of questions are going to be some more, just a little bit more complicated logarithm questions because they have more than one logarithm in the question. And we will see two different types. In this first type, we have a constant that has no log in it, okay? And so with this type, you want to, and actually with all the types, you want to get at most one logarithm per side. So if you look in this one, I have two logarithms on the left. You have to use your log properties to combine this into one logarithm. So a sum of logarithms is the logarithm of the product. And then I'm going to switch this to exponential form. And then I'm going to solve for x this way. So then, in order to solve this, I now have a quadratic in x. I have x squared minus x equals e. So I have to solve this quadratic, I have to make this equal to 0. And it would be lovely if this factored, but it doesn't factor. And so instead, I have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this is going to be my solution, except that I'm totally going to get an extraneous solution in here. So let's go back to this original question. I am taking the logarithm of x and the logarithm of x minus 1. And the domain of this function is that x has to be greater than 0 for this part and then 1 for the second part. So overall, x has to be bigger than 0. And that means that down here in this solution, if I were to take 1 minus the square root of 1 plus 4e over 2, this is a negative number, and so this is extraneous and not a solution. And so the only solution is x equals 1 plus the square root of 1 plus 4e over 2. That's extreme. This one's extraneous. So you have to be careful with logarithmic equations to only solve for numbers that make you take the log of a positive number. All right, then in this final example, most one log per side. These are all logarithm-based 2's. So I'm going to use my property of logarithms that a sum of logs is the log of the product. And now I have a log-based 2 of both sides of the equation on both sides of the equals. And so we've actually solved these before. You can drop the logarithms then. And now we have another exponential. So x squared plus x minus 6 equals 0. This one factors, yay. This factors as x plus 3, x minus 2. And I get the solutions of negative 3 and 2. The last thing we're going to do is check and make sure that those are not extraneous and one of them is extraneous. Which one? Circle the only answer and your notes are finished.